Here we are asked to show that the following can be written in the form a plus root 5 over b, where a and b are integers. Our first step when dealing with surds is to always check whether any of our surds can be simplified. Well, every number is beautiful, but root 180 looks very large for a non-calculate paper. When simplifying a surd, I want to find the largest square number that's a factor of the number inside the root. In this case, the largest square number that's a factor of 180 is in fact 36. So I'm going to rewrite root 180 as being root 36 multiplied by 5. If it's a square number, we can square root it. So the square of 36 is 6, hence it comes directly outside the root. In this case, I've got 6, and on the inside I've still got root 5. So therefore, root 180 simplifies to give us 6 root 5. Now return to my original question. Instead of write root 180, I'm now going to rewrite that as being 6 root 5. I've still got subtract 2 root 5 on the top. And on the bottom, I've still got 5 root 5, subtract 5. On the top now, I can see I've got like terms, as they both end in root 5. Therefore, they're like terms. Hence, I can simply add or subtract the numbers in front. Hence, 6 lots of root 5, subtract 2 lots. Well, 6 take away 2 gives us 4. Hence, I've got 4 lots of root 5 on the top. And on the bottom, I've still got 5 root 5 minus 5. We never leave a surd, i.e. a root, on the bottom of a fraction. Therefore, I have to rationalise. As I've got 2 terms at the bottom, I can see I've got 2 terms, as I've got a plus or minus. Therefore, as I've got 2 terms at the bottom, I'm rationalising. I must place the bottom inside single brackets, and I multiply the top and the bottom by the same 2 terms at the bottom, but I must change this sign. So if I'm going to times top and bottom by 5 root 5, but instead of being minus 5, it's now going to be plus 5. And again, the bottom, I multiply the same 2 terms at the bottom, in this case 5 root 5, but instead of being minus 5, it's now going to be plus 5. On the top, here I can see I've got a single bracket. Expanding my single bracket, I multiply the term directly outside the single bracket by each term directly inside. In this case, 4 root 5 times 5 root 5 will give us 100. If you can't do that in your head, just write it out. So I've got 4 root 5 multiplied by 5 root 5. We're multiplying surds. If the numbers are outside, we times them outside. So here on the outside, I've got 4 times 5, which will give us 20. And another rule of surds is that if you times a root by itself, you just get the number or letter back. So root 5 times root 5 is simply 5. And 20 times 5 gives us 100. Explain my second term on the top. Well, I've got 4 root 5 times 5. If the numbers are outside, we times them on the outside. So 4 times the 5 on the outside, that will give us plus 20 lots of root 5. Now expanding the bottom, on the bottom, here I can see I've got 2 terms multiplied by 2 terms. Hence I've got double brackets. So expanding my double brackets, 5 root 5 times 5 root 5 will give us 125. Again, if you can't do that in your head, just write it out. Well, 5 root 5 multiplied by 5 root 5. Again, we're multiplying surds. If the numbers are outside, we times them outside. So 5 times 5 will give us 25. And again, our laws are said if you multiply a root by itself, you just get a number or letter back. So root 5 times root 5 is simply 5. And 25 times 5 gives us 125. Multiply my next term. Here I've got 5 root 5 multiplied by positive 5. Again, if it's on the outside, we multiply them outside. So 5 times 5, that will give us plus 25 lots of root 5. Multiply my inside terms here. I've got negative 5 multiplied by 5 root 5. Again, if it's on the outside, we times the numbers on the outside. So negative 5 times 5 on the outside will give us negative 25 lots of root 5. And then finally, multiply my last term in each bracket. Here I've got negative 5 times positive 5. Well, negative 5 times positive 5 gives us negative 25. As I know, a negative times a positive gives you a negative outcome. Simplifying the bottom, I know these 2 middle terms must cancel because 25 lots of root 5, subtract 25 lots of root 5 will give us 0. So on the bottom, all I've got, collecting my number terms, I've got 125, subtract 25, which will give us 100 on the bottom. And on the top, I still have 100 plus 20 root 5. I've now rationalised as I've got no root on the bottom of the fraction. But in this case here, we're asked to give our answer in the form a plus root 5 over b. As I have a single term on the bottom, I can separate this as being 100 over 100 plus 20 root 5 over 100. We can only do that as we have a single term on the bottom. I know that 100 over 100 gives us 1. 20 root 5 over 100. Look at numbers in front. 20 and 100. Well, I can see the highest common factor in 20 and 100 is actually 20. So I can divide the top and bottom by 20. Well, 20 divided by 20 gives us 1. And I've got 1 lot of root 5, which I just simply write as root 5. And on the bottom, 100 divided by 20 gives us 5.